Okay, ladies and gentlemen. Okay, we should be able to be live here. Okay, let's see here. I'm trying to get to the stream so I can see it. Here we go. Okay, there we are. I see we have Matter Baby in the house. All right. I'm going to be dragging behind you about, oh, 15, 20 seconds. Okay, Mason. Good job, Mason. Glad you worked well. We got Matter Baby and Mason in the house. All right, very good. Okay, and everybody else who's there, say hi. Maddie was emailing me earlier for a link, so I hope she's there. Um, so we're gonna go over this the second time. I did this with Algebra 2 a little while ago, and it worked pretty well. I hope I learned something from that. Plus, I've been trying to get the streaming set up all week, just making a couple dry runs. So we'll see how it works. All right, so just tell me what you want to look at here. I definitely want to get to the calculator stuff because graphing parametrically is different on the TI-84 than with the TI-Inspire. So I definitely want to get to those. But in this quick review, 1 through 10, anything that grab you on that? I know it was the equation of the circle up there. I think I do want to look at that one for sure. Anybody? Questions, comments? It says we have 6 watching now. This is a public video, so we can have people outside our class join us, possibly. Okay, let's, number 10 wasn't shown on the second video. Okay. Oh, I see what you're saying, Noah. Very good. Yeah, so if you didn't get the hard copy, the way Noah said, you didn't see them. So basically it's changing the parameters of the parametric equation. So that we'll get to that one. Definitely. We'll save that for last. Okay. All right. In the quick review, there's not. You need to look at the point slope form at all. Is that pretty easy for you? Number 4 here, Maddie. Okay, Maddie, you made it. Any more look at that? Number 4, anybody? Basically, what it is, point slope form is um, it's y minus y1 equals m times quantity x minus x1. So basically, it's finding a point in the slope, and you already have a point. So the key deal here is finding a slope. And the way I showed finding a slope here is this one here. We go -1, 3, and 4, negative 3. And you just subtract. Negative 3 minus 3 is negative 6. And 4 minus negative 1 is 5. Just make sure you're subtracting in the same direction. That's all you need to do. And we're going to get a negative slope, and that should make sense. Okay. Comments here. That's just like 5th period class. You're talking just here, just like you do in 5th period class. Will and Aaron. All right. So your slope here. I'm sure he will. I'm sure he does. I'm sure he does. So that's our slope, and we can use any one of these points we want to watch, and so either one. We can do this second point here. I guess I'll do this again. Y minus negative 3 is going to be y plus 3 equals negative 6/5. And we're going to have x minus x1, so x minus 4. So this would be an answer to number 4. Now, is there a possibly different answer? Yeah, because what if we use that first point instead of the second point? Okay, let's go on ahead to number 6. What you do is you get a curve opening the opposite direction. So you're going to, on number 6, open to the left instead of to the right. Otherwise, it's going to be like number 5. I do want to get to number 8. And number 8 was finding an equation circle. And it's one of these deals where typically they give the easier one here for number 7 and show the one that's more complicated for number 8. And yeah, well, this is one of the papers we did earlier in the week. Exactly. I sent out the video for it on Monday. No, Tuesday actually. Yeah, on Monday I sent the video that sort of had the overview of parametric equations. And here are the standard equations for a circle. It's going to be x minus h squared plus y minus k squared equals r squared. And so basically what you have is an equation for a circle is we have h is equal to negative 2 and k is equal to 5. And so what we have is x minus negative 2, which is going to be x plus 2, squared plus y minus 5 squared is equal to r squared. Well, r squared is 3 squared, or 9. So there we have it. Okay, Noah's asking about number 6, so I'll backtrack to number 6. Okay, basically, what you're doing is you have y is equal to plus or minus the square root of negative 5x. Okay, and you see why that would be the case. So y is equal to square root of negative 5x, and y is equal to negative square root of negative 5x. So what we'll do, and Will is asking a good question, what you'll do with your paper, Will, just hold on to them, and when they're, Mr. Costa says we're going to be able to turn them in at some point, but just hold on to them unless we do. So just keep for now. That's the best I can advise. Good question, Will. Okay, so now we can take the calculator, and so we have a square root of negative 5x, then we have negative square root of negative 5x, and we graph this, and that is not what it looks like, because it turns that thing positive. Should be like this. I think I outsmarted myself on this one. Yeah, it should be. You can put the negative sign out there. You can take this negative out. Because what happens here is the bottom one doesn't flip it properly. What it should be like this. That's what it should look like. Okay. And again, I think what we have to do for that one is let's see. Oh yeah, that's right. I didn't enter it right. No wonder. If you don't enter it right, that's what happens. Let that be a lesson to you. Okay. Gosh, I was worried about this. Okay, Noah and Kyle with 4 plus 9. Guys, get back to elementary school math, guys. Okay, that's what it should look like. Okay, Noah, I hope that helps. Okay, let's not, I don't want to even worry about number 10. If you don't get to number 10 is just like number 9. No big deal. So let's get to our other exercise set. Here it is. And basically what we have is I just want to show you entering in this in the calculator. You got to make sure you put in the, I'm going to do number 1 and probably number 2 here just to show you what it looks like. So 4 cosine cubed t. So 4 cosine cubed t. Here's the calculator. And what we have to do for this is get into parametric mode. So if we press mode on the calculator and go to this row here, the 5th row down, and go to the right, parametric, and press enter, that's what we're looking at. Okay? And then I'm going to exit the second quit and go to, now we got to make sure we're in radians. And so we are in radians, and go to y equals, and then I'm going to make sure we have the equations right. 4 cosine cubed t. So here's what it is. 4. And you can do it different ways. What you do, that cube thing, and we're going to put in, you press the X thing and t pops up. And 4 cosine cubed t. So that's how you can enter it. So it's it's cubing this whole thing. So that's the x part of the equation. And the y part of the equation is this 2 sine cube t. Okay, we do that. 2 sine cube t. Okay, so that's it, really. We graph. This is what it looks like, and which is that B. And of course, that was in the exercise, the video you turned in. Now, I want to do number 2, 3 cosine t sine 2t. Three cosine t sine, oops, I could put sine 2t. So basically, it's an exercise, and so we have this infinity figure 8 in here. That's going to be B. We can go through and do the others. And I hope you're able to do that on your calculators. And really, a lot of this exercise today is getting used to your calculator. And that's one reason I did that preliminary video I sent you on Monday, to get you an introduction to that. I really think that your TI-84 is easier to use than TI-Inspired. And yeah, no, that's right. Just keep the papers until the break is over. And I did 5 in the video. Basically, you're plugging in for each of these. I want to take some time and do 6 and just show what the graph of that looks like. And then okay, basically what you're looking at is you have x equals cosine t, y equals sine t. And this, I hope, reminds you of this song. Okay, Noah, thank you for answering, Nolan. I couldn't bring myself to do it. You were just too kind. All right. So what you're going to do is, if you have a unit circle in hand, or remember what it is, it's really easy, because if you have an angle of 0, if x is the cosine of 0 is 1. Okay, and if you go to pi over 2, that's 0. What is the cosine of pi? It's negative 1. What is the cosine of 3 pi over 2? 0. And the cosine of 2 pi is 1. And then for your sine, it's going to be your sine of 0 is 0. Your sine of pi over 2 is 1. Your sine of pi is 0. Your sine of 3 pi over 2 is negative 1. And your sine of 2 pi is 0. And so what you're looking at is this. You just take these points. These are all coordinate pairs. So you have 1, comma 0. You have 0, comma 1. And you have negative 1, comma 0. You have 0, comma negative 1. And back here, you have 1, comma 0, which is the same. So what you're looking like is this when you tie it all up. If I could draw a better circle, that'd be better, but we can go to a calculator. The calculator will do it for us. So we go to graph parametric. We have cosine t. And down here we have sine t. And we graph, and this is what it looks like. And see, the proportionality is off because the way the calculator is done. If you go to zoom square, or zoom 5, zoom square, it really proportionalizes properly. So really we're looking at a graph of the unit circle. That's what it is. Okay. Now these last few, they're pretty easy to graph. So what I want to do is I want to graph number 7 and then go right to 10. No one tells me that on the video the number 10 was not apparent. So we have two equations here. 3 minus t squared, and really these constitute a parametric equation. So 3 minus t squared and y equals 2t. So we have 3 minus t squared, and we have this one here, 2t. And one thing that's really important to look at is the window. So the t minimum is 0 and t maximum is 10 because it says t between 0 and 10. And it gives an automatic t step. Now, it does not, we changed the window because of zoom square. So if I can go to zoom standard, it will take us back to a standard window, which is what this thing looks like. And what does it say for any instructions in the problem? It says use standard grid window, which is 10 by 10. Okay, so to really see better where it is, if I go to the second format, and I realize that some of you have a TI-84 and not a TI-84CE like I have. So grid line is on, and then we graph and see what this looks like. So we see we start here at x equals 3, and kind of go this direction to the left. And also the time step, I want to show you that. If we go by trace, what it does, it starts at time equals 0. And if you go to the right, you see your time increases. Now you see time is going up by these weird decimals. One thing you can do that might be helpful to you is if you go to the window, if you don't want the weird decimals for time, you can just start your t step instead of making it 0.13, which is automatic. Just change it to 0.1 and see what happens. Then we graph, and then we go to trace, and then it'll trace a tenth of the time. So it just looks neater that way. And we see where t equals 0, we're at where t equals 1.7, x is 0.11. So somewhere, okay, so it's somewhere between around here. So around y equals 3.4, that would be like our line intercept. So you go up to 3.4, and then this would be 3. So we're starting here and going like this. And what you do is you just put the arrow in the direction of time. And 8, 9, and 10 are the same thing, except we have a different time interval. And the time interval given here, as Noah asked, is between t equals -2 and t equals 4. We just go to the calculator, and we're just going to change the t spread. So we're going to go from -2, t minimum -2, to t equals 4. And then we graph, see what it looks like. Okay, very much the same, except we're starting right here. And I'm going to go ahead and go to trace. And we start out at -1, -4. Go over here. So it's the same type of thing, except a different starting point. and we trace in this direction. So -1, comma -4 is where we're starting. We're going all to 3. Is that right? -1, -4, -3, -1, -4. It goes like this. Goes up to 3.4 and over like this. And the time goes in this direction. So really, ladies and gentlemen, I know Maddie's here. I don't know if any other ladies are here. But that's really all there is to it. Do you have any other questions before we end this live stream? I'm planning on tomorrow will be sort of like a makeup day, and then I plan out sending some kind of video out on Monday, and then 2 like worksheet videos on Tuesday, Wednesday, respectively, which are going to be more parametric equation videos. And to me, the only challenge I see, or the main challenge I see, is that we're going to be using the TI-84 instead of the TI-Inspire that I use in the videos for the prior lessons I did earlier. But I hope I find that really the TI-84 is easier to use. Any questions before we end this live stream? I see 8 watching now. I appreciate everybody who's here. We have 15 total in my classes, and 8 of you are here. That's a pretty good ratio. I'm going to, this will be a live. Yeah, so Will's asking a good question. Thank you, Will. Next Thursday, I plan for another live stream at 11:30 to go over a couple other worksheets like this, where we're going to go over and have your calculator in hand. So, Will, that was a good question. Any other questions? Okay. Well, I guess I'll turn you loose for the rest of your day. Again, I appreciate everybody being here. And we will, let's see if I can find this. I'm find my end stream. So there we go. Take care. Bye-bye. Okay, Will's asking another question. So we will go over papers we do during the week on live? Yes. You can ask the questions then. All right, see you, everybody. Again, thanks and good questions, good participation today. I appreciate all of you. Have a great week. Bye-bye.